Right. Right now we're going to talk about a different type of cell. Instead of an electrolytic cell, we're going to talk about a voltaic cell, a galvanic cell, or a simple cell. Now, these cells are known as electrochemical cells in that it is spontaneous. When you complete the circuit by setting up the apparatus, what is going to happen is that a chemical reaction is going to spontaneously happen, and it's going to convert chemical energy into electrical energy. And what is so amazing about this type of technology? Well, it is the thing that actually powers our iPhones and iPads. And so it is used to do all sorts of work to allow us to enjoy all these modern luxuries that we have today. So let's look at two types of simple cells. All right. First, we have this simple cell. It's just going to be called a simple cell, and on the exam, you're going to see the keyword. This is a simple cell, or this simple cell is the reaction is spontaneous, or something like that. All right. And this is another type of cell, which is very common in electrochemical cells, which is the Daniell cell, where you have two beakers with a salt bridge in the middle and two electrodes connected by wires. How do you differentiate whether the illustration is an electrolytic cell or a simple cell? Well, by looking at the diagram, you see that there is a V on top of it, a V. This means that this V is a voltmeter. And a voltmeter basically reads electricity that is passing through, volts, the amount of volts that is passing through, which is electrons, all right? Okay, so let's get started right away with this simple cell. So here we have a setup, all right? We have a setup where you have a beaker and a salt or acid solution, and you have a voltmeter connected by wires, and the wires ends up in two electrodes. These two electrodes, very important, must be reactive metals. They should be reactive, all right? In this setup right here. And what is going to happen is that one of the metal is more reactive than the other metal. And these are electrodes, all right? So in this example, I have the more reactive metal as the purple metal, and the less reactive metal as the pink bar right here. And when you complete the circuit by putting these things in the salt or acid solution, what is going to happen in general is that electrons are going to flow out from the more reactive metal through the voltmeter. Then you're going to get a volt reading, all right? And then the electrons are going to go down into the other metal bar, and then a reaction will happen at this end. So this whole thing is a redox reaction, okay? So what's happening at the end, at this end, more reactive metal? What's happening is that you get a neutral metal that suddenly undergoes a half redox reaction, and then it's losing electrons. So that means it's undergoing oxidation, all right? This part here is known because the electron starts flowing out from here, so this part here is the negative terminal where it actually starts. And so this guy here is called the anode, all right? So the electrons are flowing out from here, all right? As opposed to the electrolytic cell, right? Remember the electrolytic cell, I'm just going to draw it real quick. This is the N negative terminal where the electron starts flowing out. So here you go. But in the simple cell, you get electrons coming out from here first. All right? So what's exactly happening here? Let's put a real example into this illustration right here. Let's call this a zinc metal. Let's say that this is a zinc metal. And what's going to happen is that zinc is going to dissolve into the solution. Let's say that this is the acid solution, okay? It's going to dissolve in the acid solution, and it's going to form zinc ions in that acid solution, and it's going to release electrons. The electrons are going to travel up the wire through the voltmeter, get a reading, and go down to the other electrode, the less reactive metal electrode. And in the less reactive metal electrode, what is going to happen is that electrons are all going to get caught up in here now, right? Electrons, all this negative charge is all going to get caught up in here. And so all the ions that are near the electrode are going to get attracted to it. And a reaction is going to happen, okay? So let's put a real example in this illustration right here. Let's say that this is an acid solution, all right? A strong acid. Let's say ECl. And this here is a copper metal. And this is zinc. And that's an anode, all right? So this one here is where the electrons get ended up. So this must be the positive terminal, and that must be called the cathode, okay? Let me just color code it right here so it's a little easier for us to read. All right, this is the plus, and this is a cathode, okay? And so what's going to happen at the cathode is that the electrons are all going to get coupled up here, and in the acid solution, the available ions are just going to be H plus, Cl minus, water, right? Right? Since water is not electrolyzed, it's just going to be water, so that's not considered. And when zinc gets oxidized, you're going to release zinc. But in reality, zinc, that's not going to really complete the circuit, because zinc and zinc, both things have kind of like the same kind of reactivity. So what's going to happen is that you get a lot of hydrogen ions around here, because this is a strong acid and it will dissociate completely and you dissolve it in water. So the hydrogen ion is going to pick up those electrons right here at the cathode, and it's going to form hydrogen gas. So it's going to bubble. I mean, the reality is that this kind of setup can be applied for a whole variety of metals and solutions, right? All you got to do is understand which is the more reactive ones, metal, and which electrode will start the process, which means you have to identify the anode. Sometimes it's given to you, sometimes you have to figure it out based on the elements that are given to you, all right? Next time we're going to talk about Daniell cell.